Well, hey everybody, Mr. Reeves back with you for our third and final video on our lesson on the Pythagorean Theorem. So in our first video, we looked at what the Pythagorean Theorem was and how to find missing lengths, either the legs or the hypotenuse in a right triangle. In our next video, we looked at using the Pythagorean theorem in 3 dimensions and how to find this diagonal length of a rectangular prism. And in this third and final video, we are simply going to be working through some problems from the practice problem set. All right, so let's go ahead and dive in and see where this fun takes us. All right, so find the length of a missing side of a triangle. So if you take a look at this first one, we have 10 and 24. Notice they together make up that right angle, which means they are the legs. So one of them is going to be labeled A, the other one is going to be labeled B, and our unknown is C. So using the way that they've got it here, all right, we've got 24 squared. Actually looks like they made A 24. My bad. I should have looked. And they made B equal to 10. Not that it matters. It really doesn't matter, but we'll follow what they did. 24 squared plus 10 squared is equal to C squared. So using my handy dandy calculator here, 24 squared plus 10 squared, I get 676. So right here I'm going to put 676, but we're not looking for C squared. We are looking for C. So I need to take the square root of that 676. And when I do that, I get 26. So the length of the hypotenuse is 26 feet. Just remember that my suggestion to you is actually to start with the square root at the beginning, and then inside it you can do 24 squared plus 10 squared, and then you get the answer in one fell swoop of 26. But both ways work. Just find the way that you enjoy. All right. Oh, good. Look at this. We got our 3-dimensional application. All right. Mr. Wu wants to ship a fishing rod that is 42 inches long to his son. He has a box with the dimensions shown. Will it fit? Will it fit? All right. Well, if you watched the previous video, and I sure hope you did, you saw that we discovered that length squared plus width squared plus height squared is equal to the letter that they used, I believe was R squared, if this is our R right here. All right, which means that if we take the square root of the length squared plus the width squared plus the height squared, we will get that distance there. All right, so let's see if that distance is longer, 42 inches or longer, right? So we are looking for it to be, we need R to be greater than or equal to 42. That's what we need. Well, let's see what happens. All right, our ever helpful, handy dandy calculator. All right, here we go. So I'm going to start with the square root symbol. And I'm going to put 40, and I'm going to square it. All right, that's my length squared plus my width is 10. That's going to be squared as well. Plus my height squared is 10. All righty. And I'm going to go ahead and close out those parentheses. And when I do that, what do I get? I get 42.4 when I round to the nearest tenth. All right. So 42.4 is what R is equal to. All right, 42.4 inches. We needed it to be greater than or equal to 42, and so the answer is yes, it will fit. All right. Okay, it actually asks you to find the length of the diagonal across the bottom, which we could do, right? The length of the diagonal across the bottom would be the square root of 10 squared plus 40 squared. All right, that would be that diagonal length, which I'm not sure if we call that S, say. I'll call that S. Okay, but when you're finding the length, that diagonal for the entire rectangular prism, you don't even actually have to do that. Okay. All righty, let's go on to the next page, do some more problems. All right, here we go. This one we don't know the hypotenuse. That would be C. So C on this one would be the square root of 4 squared plus 8 squared. All right, and then they want us to round that to the nearest tenth. So if I do the square root of 4 squared plus 8 squared, I get 8.9 when I round to the nearest tenth. All right, 8.9 centimeters. Remember to put your units. This one we know C, and we know I'll call it B, although it could be A. So for this one, it's A is equal to the square root. And remember, we subtract for this one. All right, this is going to be 14 squared minus 8 squared. So again, going back to my handy dandy calculator, second square root of 14 squared minus 8 squared, and I get 11.48. Now this time I have to round up to 11.5 inches. Okay, so this is using the Pythagorean theorem to find the hypotenuse. This one was using the Pythagorean theorem to find a missing leg. All right, what about this one? The diagonal of a rectangular big screen TV measures 152. The length is 132. What is the height of the screen? All right, so let me go ahead here and make a rectangle. Well, that one's a square, which, by the way, is a rectangle, but we don't know for sure that it actually is going to be. It should. Okay, now I think we got it on a rectangle. There we go. There we go. Okay, and then I've got the diagonal that cuts across right here. All right. Now it says that the diagonal is 152. And it says the length is 132. And these are centimeters. And they are asking us to find the height. All right. All right, so once again, we're missing a leg. Okay, so that height is going to be the square root of the hypotenuse squared, 152 squared. Whoops. 152 squared minus 132 squared. All right, so here we go. All right, back to our friendly neighborhood calculator. Square root of 152 squared minus 132 squared. And I get, all right, H is, oh, went away, 75.3. But when I see that 6, I round up to 75.4. 75.4 centimeters. All right. Okay. Dylan has a square piece of metal that measures 10 inches on each side. What is the length of the hypotenuse? Okay, so now this time we actually do want a square. Okay, so here is my square. And on my square, again, I have 10 inches. Whoa, 10 inches and 10 inches. All right, and once again, we are trying to find the hypotenuse, which is the diagonal here, right? Okay, cuts the metal along that diagonal, forming two right triangles. The hypotenuse is that cut. We want to know what that is, all right? So C is going to be the square root of 10 squared plus 10 squared, right? Here we go. Control squared 10 squared plus 10 squared. We get 14.14. So 14.1. What was this? Inches? When we round to the nearest tenth. Alrighty. See, The Pythagorean Theorem is amazing, isn't it? It's just so useful to find so many different lengths that we need. All right, a painter has a 24-foot ladder that he is using to paint a house. It must be placed at least 8 feet from the base of the house. All right, so I'm going to do this. I'm going to go ahead and make a rectangle again. All righty, I'm going to go this way this time. So over here is my house. All right, and then here is going to be the base of the ladder. That's going to be right here, okay? And they said that this had to be 8 feet. So my ladder is going to stretch from here to here. All right, so there is my ladder. And the ladder's length is 24 feet. All right, so clearly this is not to scale, which means that it's not the actual comparison because 24 is 3 times 8. All right, so we want to know, right, how high can it reach on the house? All right, so once again, that's a leg, right? So h is going to be the square root of the hypotenuse squared, 24 squared, minus 8 squared. All right. Seems like we're doing the same thing over and over and over again. 24 squared minus 8 squared is going to give me 22.6 when I round to the nearest tenth. 22.6 feet. All right. Alrighty. What is the longest flagpole that could fit? Oh, it's another 3-dimensional one. Woohoo! All right, here we go. All right, remember, what is our relationship? We know that the length squared plus the width squared plus the height squared is equal to r squared, right? But if we take the square root of all of that, we get r. So what do we want? We want the square root of 12 squared plus 2 squared plus 2 squared. And that's going to give us r. Square root of 12 squared plus 2 squared plus 2 squared. And when I do that, I get 12.3. So r is approximately 12.3 feet. All right, the longest flagpole in whole feet, all right, would be 12 feet. So the answer to our question is 12 feet. Because 12 will fit because it's smaller than 12.3, but 13 feet obviously is not smaller than 12.3. So in whole feet, the longest flagpole is 12 feet. All right, I'm going to skip to this broken tree one. This poor tree got struck by lightning 12 feet above the ground. What was the height of the tree? All right, here's a case where you have to read the question carefully because it's asking for the height of the tree. Well, the height of the tree is going to be 12 plus c. So h is equal to 12 plus c. So we're going to find c and then we're going to add it to 12. All right, so 12 squared plus 39 squared, well, that would give us c squared, so we're going to do the square root of 12 squared plus 39 squared, and that's going to give us c, okay? All right, here we go. 12 squared plus 39 squared. All right, and I get 40.8. All right, so 40.8. So h is equal to 40.8 plus 12. So what do we get? We get about 52.8 feet. Okay, explain your reasoning. If I were to write it out, I would say the height of the tree is equal to the height of the stump, right? Plus the height of the broken part of the tree Using the Pythagorean theorem, I found the height of the broken part of the tree. I added it to the height of the stump, and I got the total height of the tree. 12 foot, by the way, is a very high stump if you think about it. All right, that's 2 6-foot people standing on top of each other. All right, a couple more, and then actually just one more. Just one more. We're going to do number 12 here, and then we're going to be done. All right, Main Street and Washington Avenue meet at a right angle. A large park begins at this corner. Joe's school lies at the opposite corner of the park. Usually, Joe walks 1.2 miles along Main Street and then 0.9 miles along Washington Avenue to go to school. Today, he walked in a straight path across the park. Why didn't he do this a long time ago and return home on the same path? What is the difference in distance between the two round trips? Okay, so again, if you're going to get this correct, it is very important you read the instructions carefully. Okay, so let's make a sketch of this. So we have Main Street and Washington Avenue. All right, so I'm going to call this one Main, and I'm going to call this one Washington. Okay, and they meet at a right angle. Okay, a large park begins at this corner. Joe's school lies at the opposite corner of the park. Okay, so over here I'm going to put school. All right, and right here is where the park begins. Okay, Joe usually walks 1.2 miles along Main Street. Okay, 1.2 miles. And then 0.9 miles up Washington Avenue. Okay, once again, this is not to scale. Everybody knows 0.9 is smaller than 1.2. All right, if I wasn't in a rush, I would redo these. But you know what? It's really not going to matter. Okay, so if Joe starts here, normally what he does, is he walks here, and then he walks there. All right, and then he would walk back here, and then he would walk back there. All right, so his normal, or usual, I guess they say, his usual round trip would be 1.2 plus 0.9 times 2, because he does that twice. All right, I think I could do this without a calculator. 1.2 plus 0.9, that's going to be 2.1. 2.1. And 2.1 times 2 is going to be 4.2 miles. So his normal trip is 4.2 miles. But he got smart, or he was running late, or he was desperate, or maybe I don't know what's going on. But he decided to cut across, right? And then he's going to come back. All right, I'm going to make them both green because he's going across the park like that. Okay, so it's going to be the hypotenuse, right? So C, again, C is going to be the square root of 1.2 squared plus 0.9 squared. And then we're going to have to take that and multiply it by 2. Okay? So here we go. So what do they call this? Today it's going to be 2 times the square root of 1.2 squared plus 0.9 squared. Again, 2 of them because he's going there and back. All right, and the great thing is you could put all of this in your calculator all at once. So I'm going to go 2 times, and then I'm going to go the square root of, remember, scientific calculators, no order of operations, so it's great. 1.2 squared plus 0.9 squared. All right, so there is that diagonal. We're going to have 2 of them, and when we do that, we get 3. Wow, exactly 3. Well, look at that. Okay, so what is the difference? Okay, Well, remember, difference means the answer when you subtract. The difference is going to be 4.2 miles minus 3 miles. That's going to be 1.2 miles. So he saved a whopping 1.2 miles by cutting across the park. If I were him, I would cut across the park every day. There's our park that he's cutting across, right? Unless there's like a big scary dog or some bullies that beat him up, or there's a reason there. All right. Okay. That, ladies and gentlemen, is our conclusion of our lesson and practice on the Pythagorean Theorem. Until next time, have a great day.